Hello class, reviewing last night's lesson, special products. Just a reminder again, I know you can use the distributive method and FOIL to do these, but I highly recommend using these shortcuts. If you're not using the shortcuts, factoring is going to kind of come back to bite you when we start to get there. So I highly recommend using the shortcuts. Use them or lose them. Number 12 is a squared plus 20a plus 100. Number 13, I'm not going to write it down, just say it. 13 is b squared minus 12b plus 36. Let's just review those two real quick. Number 12, since we have the same product twice, it's the same thing as a plus 10 squared. The same binomial twice, I mean. And so we know it's going to be the square of the first term, which goes here, the square of the last term, which goes at the end, a squared plus 2ab plus b squared. And then in the middle here, it's going to be 2ab. And what we mean by ab, I don't mean the letter a in this problem. I mean a is the first term, b is the second term. So a times b, or a times 10, is 10a. And then when we multiply that by 2, we get 20a. So that's using the shortcut. For the second one, using the shortcut, again, it's b squared minus 12b plus 36. That middle term is 2 times b times negative 6, which is negative 12. And the last term, positive 36, is negative 6 squared, which is positive 36. Number 14 is h squared plus 14h plus 49. 15 is x squared plus 12x plus 36. All right, continuing on with number 16. Number 16, this time we have the... All right, for this next one, number 16, all they did was reverse the number and the variable, but we're going to treat it the same way, just like we did before. So it's going to be a squared, which is 8 squared, gives us 64. And then it's going to be 2ab in the middle, so it's going to be negative because of that negative sign sitting right here. Negative 8 times negative m is negative 8m, times 2 is negative 16m. And then finally, negative m squared is positive, negative m times negative m is positive m squared. And so that would be our final answer. Now, if we were going to write it in standard form, we would flip these two around. But since it didn't ask us to, we're okay there. So just kind of to keep in mind, we're always going to have a squared plus 2ab plus b squared in this scenario, or a squared minus 2ab plus b squared in this scenario. It's going to be minus if there's a negative in the middle. It's going to be positive if there's a positive in the middle. Notice that the plus b squared and the a squareds are both always positive because it's always going to be that number times itself, meaning it always has to be positive. Okay, for number 17, you should have 81 minus 36y plus 4y squared. For number 18, you should have 4b squared plus 12b plus 9. For number 19, we'll go over 20. For number 19, we have 25t squared minus 20t plus 4. For number 20, we have 8h minus 4n. Don't you love when they use h and n in the same problem? Squared. The first term squared is going to be 64h squared. And then we know it's going to be negative because of this minus in the middle. 8h times 4n would be 36hn. And now we need to multiply that by 32. We're going to multiply that by 2 and get 64hn. And then positive 16n squared because it's the last term squared. Again, use those shortcuts. Use them, use them, use them. For number 21, part A says, show how the combinations can be modeled by the square of a sum. So if we know what the square of a sum means, we're squaring a sum. That's what that means. Squaring a sum. Hopefully you caught that. So how can we represent this by the square of a sum? Well, if you look at the Punnett square there, which I think is what those are called, you guys would know because you're in biology. But if you look there, each side of it is large T plus little t. And so if we want to represent the area of this here, large T plus little t squared, shows how the combinations can be modeled by the square of a sum. And if we break this out, we're going to get t squared plus 2t little t plus little t squared. Then it says, predict the percent of children that will have both dominant genes, one dominant gene, and both recessive genes. And you can tell this just by looking at the expression that we break out. It's all right there. Both dominant genes, that's T and T, there's only one of those, 1T squared. So there's a 25% chance that they'll have TT. 2 times big T, little t, dominant recessive. So there's a 50% chance you can have that. And then there's 1 little t squared, so there's a 25% chance you'll have double recessive genes. You guys probably already knew that, though. All right, so then the next set of questions was 37 to 48 all. I'm going to read some of these out loud. Number 37. For some reason, this is... Oh, no, I see. Okay. 37 is 9a to the 8th minus b squared. Let's go over this one. Okay, I wrote them backwards, but it doesn't matter because of the commutative property. So, because I have the same exact thing twice, we can see that we have the same exact thing twice. One's positive in the middle, one's negative in the middle. That means I can cut straight to my shortcut. I know it's going to be a squared minus b squared. And by a squared and b squared, we mean the first term and the last term. So, I know it's going to be 9a to the 8th, because I'm just squaring 3a to the 4th, minus b squared is b squared. That's it. For number 38, you end up with 25x to the 4th minus 10x squared y squared plus y to the 4th. Double check that, make sure you're getting the right answers. For 39, 64a to the 4th minus 81b to the 6th. For number 40, since it's got a fraction, I'll write it down because I know how you guys are with that. For number 40, we're going to look at this as a squared plus 2ab plus b squared. So I'm going to square the first term, which is going to give me 9/16 k squared. And then I'm going to multiply 3/4 k times 8. Let's do that off here to the side. 3/4 k times 8. 8 and 4 are going to cancel, leave me with 2 times 3 is 6. So I get 6k, and then I have to multiply that by 2 to get the 2ab. Here's a, here's b, here's my 2. And so when we have plus 12k, and then plus the last term squared is going to be 64. So that should be your answer for number 40. Number 41 is very similar. You should have 4/25 y squared minus 16/5 y plus 16. Number 42, you should have 49z to the 4th minus 25y to the 4th. All right, now let's look at 43. For 43, we can use a little bit of a shortcut here, and then we're going to have to multiply it like we normally would. So if you look at the first two binomials, just ignore the m plus 4 for now. Just leave that off to the side. If you just look at the first two, we're going to use our shortcut of a squared minus b squared. So we get 4m squared minus 9. And now we're going to multiply that to m plus 4. We're going to bring the m plus 4 back in. And if you use the distributive property, FOIL, whatever you're comfortable with, you should end up with 4m cubed plus 16m squared minus 9m minus 36. If you didn't get that, go back, check your work, see if you can find out what mistakes you made. Number 44 also utilizes a couple shortcuts, and if you look, we can rearrange number 44 to be r plus 2, r minus 2, and I hope you did this, and then r plus 5, r minus 5. This is going to make it a lot easier. So if we look at this as kind of two separate problems to start with, the first one, we can use a squared minus b squared again. We can use that shortcut. It's going to be r squared minus 4. The second one is going to be r squared minus 25. And now that we've used our little shortcuts, now we can just treat it like a normal FOIL or distributive property problem. So we're going to do r to the 4th. Then we're going to have negative 25, negative 29, r squared, and then plus 100. And that's your final answer. But use those shortcuts. Utilize them, utilize them, utilize them. On to 45. For number 45, it says write a polynomial that represents the area of the figure at the right. And so if we're going to try to find the area of this figure, there's two different things that we need to add together, right? There's the first square, which is x minus 1 squared is its area. And we need to add that to the area of the second squared, which is x plus 2 squared. And this is a good point, a good time to use our shortcuts. I know that this one's going to be a squared minus 2 2ab plus b squared. And then I'm going to add that to a squared plus 2ab plus b squared. Combine like terms and we get 2x squared plus 2x plus 5. That's your final answer. Hopefully you got that. Let's try that again. Hey, now I'm recording. For number 46, it says the flying disc is shaped like a circle, has a radius of x plus 3, so I use the formula for the area of a circle. Plug in x plus 3, use the shortcut, then distribute pi. Your final answer for part A, pi x squared plus 6 pi x plus 9 pi. For part B, if we were to put a hole in it, that means that we would have to subtract from our final answer. So we would take pi x squared minus 6 pi x, or plus 6 pi x plus 9 pi. And now we're going to subtract a circle that has radius of x minus 1. So we're going to subtract pi times x squared minus 2x plus 1. And when you do that, your final answer should be 8 pi x plus 8 pi for part B. All right, last two problems are 47 and 48. For 47, you should end up with a final answer of 6x plus 3. And you're going to get that from doing x plus 2 quantity squared minus x minus 1 quantity squared. Use your shortcuts, combine like terms, 6x plus 3 is the final answer. For number 48, you're going to take the area of the large triangle and subtract the area of the squared. So it's going to be x plus 6 times x plus 5. And we're going to subtract quantity x minus 3 squared. And when you do that, you should end up with a final answer of x squared plus 11x minus 6. That's it for the homework. If you had questions beyond that, please do send me some questions via the Remind app, and hopefully I'll get to those soon. Today I'm just going to introduce Section 8.5 using the distributive property. This and the next video will both be on this topic because I don't want to move too far past it, as factoring can be a bit tricky if you don't know what you're doing. So I want to make sure we slow down here, follow the rules, and make sure we understand everything. Now the good news is we've talked about this before in class. We've talked about using the distributive property backwards, but I'm going to start today with just a quick example to make sure we all understand what's going on. So let's say my instructions were to simplify this statement. 3x times the quantity of x squared plus 4y. So if my instructions were to simplify that statement, that means I'm going to distribute, and I would end up with 3x cubed plus 12xy. Now what we're going to be doing in this section is starting with 3x cubed plus 12xy and being asked to factor. And factoring is basically just the reverse of what we just did. Instead of making something simpler, we're making it more complex by breaking it into its many parts. And we're going to do that using the distributive property in reverse, which basically means we're going to be dividing instead of multiplying. But to do that, what we're going to do is we're going to look at the greatest common factor of both terms, the GCF, as we might say. So we look at these as two separate terms, the individual monomials, and we say, what's the greatest common factor between the two? So first, by just looking at the two numbers, 3 and 12, what's the greatest number that divides both of those? And that's going to be 3. And then looking at x cubed and xy, what's the largest number of variables I can take out of that? How many can I divide out? What's the greatest common factor between those two terms there? And it's going to be just one single x. And if I do take that out, what's left over? So now instead of multiplying, I'm going to divide both of these by 3x. And when we do that, we end up with x squared plus 4y. If I would divide both of those by 3x, that's what we'd be left with. And so going from here to here is factoring. It's the reverse of the distribution process. And so let's look at a couple more examples. Okay, so in your notebooks, I'd like you to pause after you write down this problem. Try to factor it yourself. If the instructions said to factor this, what would you do? Try that on your own for a sec. Okay, now that you've tried it, we're going to take out the greatest common factor of 27 and 18. What's the largest number that divides both of those? And that number is 9. And now we have special ways of finding that we'll talk about in a minute. And then what's the largest divisor of y squared and y? And that's going to be one singular y. So I can factor a 9y out of both of these terms and see what's left over after that. So if we're going to reverse distribute or divide out 9y, I'm going to be left with 3y plus 2. And now to see that I did the problem correctly, if I look inside my binomial here, I shouldn't have any other factors. So if I had 6y plus 4 or 6y plus 3y, then there would be other things I could take out or combine. But here we see 3y plus 2. There's no other factors that can be divided out. And so if you accidentally divided by 3, or maybe you forgot the y, you should look inside your binomial and see there's still some other things you can factor out of that, and you don't have the greatest common factor. We want to get the greatest of them. All right, so as you're looking for a greatest common factor between numbers, let's look at this example. Negative 4a squared b minus ab squared plus 2ab. And if we're asked to factor this, what we're going to do is look at each individual term and its prime factors. And when we say prime factors, what we mean is the smallest multiple of each, breaking it down into its smallest components based on multiplication. So the first two are both going to have negative 1 as a prime factor. 4, the smallest you can break 4 down into is 2 times 2. 8 is 2 times 2 times 2. A squared is the same thing as a times a. Here we have a, and then b squared is b times b. And we have 2ab. Now you won't have to do this for every problem, but if you ever get stuck and you're kind of confused on how to factor, then do this. Write down the prime components of each one. And if you look, you can see each of these numbers that I've written out. None of them can be divided any further. And so now we're going to look and see what they share. I see a 2 in all of them, but only one 2. Now the second and the third one, the negative 4 and the 8, they both share another 2, but since the last one doesn't, we're not going to include that. They all share an a, and they all share one b. If they shared multiple a's and multiple b's, then we'd be circling those 2 and taking those out. So that means my greatest common factor is 2ab. And when I remove that, what I'm going to be left with is whatever I get when I divide each of these by 2ab. Divide by 2ab, divide by 2ab, divide by 2ab. So the first one I'm going to be left with negative 2a. The second one I'm going to be left with negative 4b. And the last term I'm just going to be left with positive 1. Don't forget to put the positive 1 there. It doesn't just disappear. If you ever want to check your work, you can redistribute this back through and you should end up with the original statement. Go ahead and write down this example and then try factoring each of the terms. Try to factor into the greatest common factor. Take out the GCF and write it as we just did the last one. So go ahead and try that. Okay, if you did, you'll notice we have 7, 21, and 1. There's no number that we can really take out of those except for 1, so we don't write anything. Now you might be thinking we can take 7 out of 7 and 21, but if we can't do it for all of them, then we can't take it out. Then we look at the variables and we see u squared, we see u, and we see a u. So that means we can take out one u because they all share at least one u. Here we have t squared, and t. They all share at least one t. Now we're going to write what's left over if I divide each of these by ut. I'm going to have 7ut plus 21t minus 1. And now if I look in what I wrote in red inside here, there's no other factors I can take out of these three terms, so that means I found the greatest common factor. So this is my final answer. Okay, that's it for today. I don't want to go through the whole section yet. It's going to be a lot to try to do in one session, so we're going to split it up into two. So tonight's homework's pretty small. Just do those questions. Remember to make sure you're showing your work. And here work can be shown by you breaking it up into its components, trying to see what the true greatest common factor is between these numbers. If you have questions, go to the Remind app. I'll try to be checking that as often as I can. And then we'll continue tomorrow with the other things in this chapter.